Your Edge fleet, your Edge project, you need to make this successful because you're investing a lot of money in it, not just today, but tomorrow, next year, and probably 5 years from now. Join us on this special episode of the Tech Field Day podcast as we talk with Sachin from Zededa and also Guy Currier. Welcome to the Tech Field Day podcast, where we bring together a group of IT technical experts to discuss a single idea around key concepts in the industry. This podcast features a variety of perspectives from members of the Tech Field Day delegate community and is often recorded in association with one of our events. Tech Field Day is part of the Futurum Group, and this podcast is also published on our sister company's site, TechStrong TV. On this episode presented by Zededa, we'll be discussing the premise that without fleet lifecycle management, your Edge projects will fail. Before we start the discussion, let's meet who's on the panel today.
Hi, I'm Guy Currier. I'm an analyst at the Futurum Group. AI infrastructure, Edge, as well as some of the things that fuel those, like chipsets, containers, and so forth. Those are my areas of coverage.
Hey guys, I'm Sachin Vasudeva. I am the VP of Product here at Zededa, and I am responsible for driving the product strategy, pricing, as well as driving the portfolio around Edge AI, as well as management and orchestration solutions.
And of course, I'm Alastair Cooke. I'm an event lead here at Tech Field Day and wanted to look at the kind of context of Edge deployments and some of the things that make Edge deployments quite different to how we might sort of view things. Sometimes we view Edge deployments as and Edge projects as being a cross between being a cloud platform and being like managing a fleet of laptops. And while it has elements of both of these, its own quite unique complexion. These projects to deploy intelligence and applications out to the edge are very different to giving a group of traveling salespeople their laptops or using cloud services where we have near infinite resources available in front of us. One of the other elements on this is that edge deployments tend to be characterized by a huge number of very small deployments. We end up with devices at every branch or attached to every oil well or to every ship that we have traveling around the world, and that's lots of small deployments is very different from dealing with clouds that are massive. And so things that sort of make sense in the public cloud and make sense if you have a small number of laptops that are in the hands of skilled and experienced staff don't necessarily translate to where you're putting a whole lot of devices out in hostile locations with potentially staff who really don't care about those devices at all. And that makes things quite difficult as we scale and deploy these applications, and particularly as we're running these edge locations for longer periods of time, as day two operations start to dominate what we're actually doing. Moves, adds, changes to the application set and these things that are out at the edge. Sachin, as you're working with customers, particularly those who are adding functionality like the AI that you're focusing on, what are the sort of challenges are they hitting with managing their fleet of locations as changes come in?
Right. There's actually quite a few challenges that we are seeing, especially with AI coming more and more apparent and more organized and more structured. First and foremost, so fleet management is about managing total cost of ownership of your devices, the life cycle. And that includes also the not just updating the software stack, but also updating the applications that run on these devices. So with AI, what's going on is the applications are iterating faster. There are AI models that are coming around with newer technology, interfaces. Without even talking about Gen AI, if we take the classic machine learning models, they are now starting to be fully commoditized. And so we are seeing the challenge of taking and packaging these models in a way that they're lightweight and they're easily deployable. Second, the version management of these models becomes super important across the fleet. You might have different versions deployed for different application types because one version sort of exists and continues to operate as it was trained, but another version might be required because the data has changed for a particular region, for a particular site. So within the fleet, there are parts of the fleet that will require the sort of model management to be different versions. So packaging will change accordingly. The ability to then coming back to Lifecycle is automation, right? So how do we easily drive uh, changes that are maybe driven by the IT team for security purposes, but the OT team does not want to apply the change right away. So there is a management for the edge when it comes to fleet management to actually hybridize this IT OT bridge and make sure that there's a right level of approval that's built into this fleet orchestration solution as well.
I think that when I think about, this is really good insight, Sachin, because when I think about, let's take the word fleet out for just a second. When you think about managing edge applications, to start with, there are at least three basic dimensions to this, because there's the management of the physical device and its physical environment. There is management of the payload. And then there's management of communications, whether it could be a data collection device, or it could be a data utilization device, a drone or something like that. Data utilization just meaning the application performing functionality of some sort in the field. But when you add AI into this, that creates an added level of complexity and variation. The variation of, you talked about machine learning. There's a certain amount that can and must happen for disconnected devices in the field. There's data collection and training back in the core that's required. You might want to do pre-processing for that. So the relationship of the ultimate application to the AI is an added area of management. And it was helpful to me for you to open up this idea of the provisioning and the payload and the application and versioning position in the life cycle. That also all needs to be considered part of fleet management as well. And I suppose, and this might be my question back to you, Sachin, I suppose that part of the game here for customers is to understand where they need to focus, because you can't focus on six things. You need to focus on the most important elements of that management part of it that comes after development when you're on day one and beyond. Is that right? And what sort of shape does that focus take? How do you advise your customers where to focus?
That's a good segue, right? So back to sort of let's when we talk about fleet and life cycle, right? All these words are sort of interlinked. Let's talk about the life cycle and the anatomy of an AI application. Right. Let's start there, and then we can talk about the focus that we need customers to sort of really put energy on. So the first and foremost, you mentioned, right? There's a training that happens. There's data that's involved, right? All of that can happen in a centralized location where all of the centralized data lake is collecting all this info. And once this training has occurred, however, there is a need for the customer to take this, package it in a way that it's lightweight, so it fits the edge form factor. You might be deploying this on a small sort of a NVIDIA Jetson based platform, which has limited resources, or you might be deploying this on a high-end GPU AI server, which has a lot of resources. So there has to be a deterministic, or there's a determination on the resource at the edge, and ideally you don't want to think about it at the time of thinking of deploying this. So ideally you want to sort of push that decision to somebody else. Like, where does it go in a consistent way? And if the resources are not available, what happens then? Then if you continue on the life cycle, right, once you move into a deployment, then there's monitoring, which is observability. How is my application performing? How is this AI model accuracy? Is it up or down? Is there data drift? To your point, right, data collection has to occur. Typically, that um, ecosystem is driven by data collection not at the edge, but data collection all the way, making its way all the way back into the cloud. So there's an obvious cost to pushing data all the way back and then figuring out if the model drift occurred or not. So let's take this apart, right? So on the deployment side, the identifying the target, identifying the right environment, and then packaging it to the right form factor, and then monitoring means maybe collecting the data at the edge, and then having something to do with retraining the model at the edge. Those become sort of really sort of big drivers for driving this. So now, what we are starting to talk about with customers is their focus needs to be on the model itself. I mean, they have the domain expertise on the business logic that gets attached to the model. The model is doing its bit, which is the inference part. But once the output of the inference comes in, right, they have to bring some post processing logic that helps, conclude to certain business decisions that happen either at the edge or happen maybe centrally. And so let's help you, Mr. Customer, focus on solving those problems within the application and take the rest of the application challenges around packaging, deploying, fitting it to the right form factor, observing or collecting data. Leave it to an infrastructure provider to help you get all that info, so that you can actually come back and then decide whether your model actually worked properly, whether you're able to glean the right information to make the right business decision, whether you can automate around it deterministically, or whether you need to continue to sort of iterate and continue to what we call test and deploy and iterate, right? So, and we know with AI, uh, iteration and testing, and what we call A/B testing, is the norm nowadays, right? Because a single model doesn't fit all use cases, whether it's overfitted or underfitted. But and so these so focus on the business logic, focus on the outputs of these models, and let us take care of the rest.
I mean, it starts to get really interesting when you're thinking about variation based on local conditions and learning and maybe some sort of automated or not fully automated iteration and versioning. I mean, that's like the mother of all forks. I mean, that's not necessarily something it's the sort of thing that can give a customer pause. But it sounds like Zededa's point of view here is that there are certain elements of that that are more technical than domain related. If you're in ag or if you're in energy, you want to focus on applying your you call the business, I think business rules, but it's really about how you're operating your company, what your go-to-market model is in energy, in ag, and certainly focus AI development, data management, and all that sort of thing on that domain. And Zededa's point of view is there are technical elements of this that can and should be handled by provider, tool, software. Yeah, is that right?
That's absolutely correct.
I think one of the things I wanted to hit on was quite a lot of what you've talked about, Sachin, is true for people who are doing AI deployments that are not edge deployments, that are doing this in their own data centers as well. A lot of that same process goes on for a deployment in your own data center. But that's quite different from where the actual business logic is being applied at hundreds of locations spread around the world, and that decisions need to be made locally inside each of those locations for speed and cost reasons. And particularly one of the things we see is the intermittent connection of some of these locations. And that adds another dimension that maybe the model that we believe is our best, most accurate model is only in 90 of our 100 locations because 10 of them have been offline during that update, and maybe 2 of those were offline in the last update as well. And this is that perspective on fleet management and wanting to have policy-based management across it rather than having to manage every single site individually. And I think that's really where you're talking about handing off this responsibility for the essentially providing a platform and an infrastructure layer in a consistent and predictable way. I think that difference between doing this in your own data center to doing it across lots of potentially intermittently connected low power locations is what's really different in edge deployments versus cloud or on premises.
Yeah, that's a great point. And two words come to mind when we talk about these two items where you start off in this centralized mode of operations, and then you're trying to really deploy something at the edge which has different constraints, and you may not have tested for it, you may not have thought through all the implications of it. So quantization and optimization, right? So we believe that that is a significant effort, in especially as the edge, as you're aware, there are a variety and diversity of platforms out there, right? So, we know there's a constant sort of um, uptick on the number of systems or platforms or chips we're seeing now in the market. So, for example, NVIDIA is pushing the Jetson infrastructure and the Jetson chip platform, and it's actually revving it super fast. So, within a couple of years, we've already seen, like within this year, we've already seen two variations come out, and the last one, the Jetson Thor, was based on the Blackwell GPU. But that's not alone, right? I mean, you've got Qualcomm with their NPUs, and then you've got custom chip makers like Halo, and with TPUs, and then you've got the hyperscalers bringing their own flavors of the chips that they're also building, which they might want to also push towards the edge. So we are seeing a plethora of all these systems, and so when you start thinking about quantization and optimization, you have to think about the common elements that exist from an infrastructure point of view to help you deploy this in a consistent way without worrying about getting a hit on your accuracy or hit on your performance. Now, um, it is a tough problem. It's not an easy problem, but we love to try to address this in a way that we can address it one step at a time, and ensure that we can actually move towards some level of standardization. There's a lot of open source efforts going on towards taking the work that is being done for one specific chipset maker, and then bringing it as a generic approach to inferencing, for example. And inference engines are sort of are taking on that. The open source community is taking on that effort as well.
I wonder though, if I rather feel like this is an issue that's not talked about much in Edge, and maybe it's because it's a non-issue, but that's diversity of platform, meaning hardware platform, meaning edge device platform. My general sense from talking with customers and especially application managers over the years, because this has been going on for a long time, including AI at the edge, it's been going on for quite a long time, is that uh, any one application actually can have several different types of edge devices. It's not just a question of architecture; it's a question of size, rugged, non-rugged. Does it have a human interface? Does it not? Is it collecting? In other words, is it mobile or is it fixed? What kind of connectivity? That single applications have diverse hosting environments, and I'm sorry, but I don't see K2S as really solving this. I don't see anything solving this other than a way to, I'm going to use the word centralize, but I just mean sort of in a virtual sense, centralizing development so that there is a way to develop one application, but that can have its various functionalities deployed into onto diverse hosts. So, so I just wonder if, from the analyst perch that I sit on, if that's just me speculating or if that's actually a reality. And if so, why isn't it talked about more?
So it's the same idea that a lot of companies in the networking space talk about when they built hardware abstraction layers, right? The HAL. So you're right. At some point, when the rubber meets the road, and you're actually trying to bring a HAL that actually works on a specific platform or device, right? You've got to make sure that it actually works end to end. So it's the same concept for us, right? We will handpick a few that are most predominant in the industry and start with them, and then as adoption occurs across other players and emergent or existing players coming in, and it's a customer driven, right, adoption, then we'll start to address it as part of this notion of a HAL, or this notion of an abstraction interface, which starts to abstract it. What you're correct about is that we would have to pick and choose sometimes. Sometimes it's not feasible. The portability is a desired sort of, and consistency of workflow is a desired end state. But for some applications, we may never achieve that. So especially like we're seeing a very diverse set of applications. But I think the vendors we're working with are also trying to address that. So HMI related, like where you have touchscreens, the apps are going to be very different. There's going to be a lot of sort of interfaces that built in around the touchscreen and the actions, and then versus an industrial PC, which is not looking for that interactive mode of operation. So we do it comes back to the anatomy of the application itself and what you're trying to do. And if you break it down into a series of microservices with accompanying models and accompanying data for managing drift, we can argue, how we then package this, whether there's a UI or not, UI component or not, becomes an interesting conversation. To your point, but yeah, I mean, the model will certainly have a dependency, and the runtime of the model will have a dependency on the type of hardware you deploy. That is
Yeah,
significant.
that's the reality. I mean, Alastair, you've lived that. That it's these reference platforms and everything. They just sound really great when you're in buy mode, but then when you're in use mode, that's when
Yeah.
you have the company breathing down your neck and
Yeah.
setting off your beeper in the middle of the night, right?
There's also the element that your edge deployment is not going to be a rip and replace everything when there is an update. That you'll end up, as you see, with that diversity of hardware. Even if you have multiple sites that have exactly the same requirements, the same application set, you may have one site that has hardware that's 6 months old, another site that has hardware that's 4.5 years old. And managing that diversity, making sure that we're not pushing down a model to that old hardware that is so heavily quantized that it will fit on the hardware but no longer produces a useful result. There's absolutely some challenges around fleet management across that diversity, and then flagging back to the hardware lifecycle as well as to the application and the infrastructure underneath. The lifecycle of these things are all tied together and changes driven by the business need. But there's a very high high cost for changing the hardware at all of these edge locations compared to trying to shoehorn whatever application we can get into the hardware that's already there. This is what leads us to 4.5-year-old hardware at sites, because it's sitting out in an Alaskan mine, and it's just monitoring, as one of the examples I've seen, is monitoring a conveyor belt to see if one of the staff has gotten onto the conveyor belt because they're maybe not in good working condition. The staff, that is, not the conveyor belt. So yeah, that diversity is a challenge.
That is exactly right. So there's a promise of an abstraction and a reference platform, but the reality is there's a diversity to manage, and it becomes half process and half technology. So so yeah, one of our customers has more than 18 vendors.
I don't think customers are asking for this problem to be eliminated, but that's what vendors are offering. We have this magic potion that's going to eliminate this problem. I think customers are looking for a way to rapidly and relatively simply be responsive to these scenarios and situations. A node goes out, they need to be able to do something about it in a reasonable, because, as they say, stuff happens.
Yeah. So I would argue that uh, for AI, right, it's a wild west. So and so there is some level of standardization that can happen. For example, the inference engines out there like OpenVINO, inference, the your TensorRT, or like the new Dynamo, or ONNX, right? So we will see some level of settling, and our customers are asking us, well, tell us upfront if you're comfortable driving ONNX, then we'll align to ONNX as a format for packaging. And so there's that level of conversation also happening at the same time. So I, while there is no magical cure for the diversity of hardware, there is definitely a runtime that can be, that the format, for example, could be agreed upon. It could be an agreed upon. It doesn't mean it's an industry wide standard that's adopted, but adoption and sort of this goes hand in hand. So I think if you can agree upon one or two or a couple versus bring a lot of flexibility into your fleet management, then you can really sort of own and manage it.
I think it really frees the let's say the device management team too, to respond to more quickly to new opportunities, not just new applications. I'm thinking, entering new fields, new operational zones and areas, whatever it is. I'm losing my lingo here because I don't have that domain expertise necessarily, but it allows them to be more creative.
As always on the Tech Field Day podcast, our guests could continue to discuss and learn from one another for hours, possibly days. In fact, that's probably why we have longer events at Tech Field Day. But I'd like to thank you all
Yeah.
for joining us today at the Tech Field Day podcast. And before we go, where can the people watching, people listening, connect with you and continue this conversation?
Well, you can find me at my writings at futureofgroup.com. And as I attend events and conferences or do shows like this one, I tend to post in LinkedIn. That's a good place. And I'm also at Blue Sky, at Guy Currier, Blue Sky dot whatever it is.
You can find me at on the Zededa.com website, where you can reach out to the Zededa team, as well as on LinkedIn. So yeah, happy to provide more insights as needed, and looking to engage. Yeah.
And of course, you can find me, Alastair Cooke, on any of the Tech Field Day and Future Insights, as well as on LinkedIn. Do make sure to check out the previous presentations that we've seen from Zededa. You'll find them all on the Tech Field Day website. If you just go to techfieldday/company/Zededa, you'll find all of the great presentations from Zededa. And so thank you for listening to this episode of the Tech Field Day podcast, showcasing Zededa's edge expertise. If you've enjoyed this discussion, subscribe on YouTube or your favorite podcast application so you don't miss a single episode. Do also remember to give us a rating, a very positive rating and a nice review. This podcast was brought to you by Zededa and Tech Field Day, the home of IT experts from across the enterprise and a part of the Futurum Group. For upcoming events and more episodes, head to techfieldday.com/podcast or view us on TechStrong TV. Thanks for listening, and we'll see you next week.